welcome back to one more video lecture which is based on IoT, and it is the part 1 video lecture. I have already uploaded the part 2 video lecture, so watch that full. So this video will be for those who are just focusing on cracking the university examinations. For that particular audience, this video is for you guys. We will be covering the part 1 or the concepts which are not covered in part 2, which is I uploaded the first. So this is the part 1 of the Boon of IoT series. So without wasting any time, just dive into this. And if you are liking this kind of videos or informative videos, then please like, share and subscribe this channel so that we can create awesome content here. So talking about IoT or Internet of Things, what you actually know or what you actually learn about that. So let's understand first that in detail and then we will just move towards it. So IoT describes the network of physical objects or things that are embedded with the sensors, softwares and other technology for the purpose of connecting and exchanging data with other devices and systems over the internet. So what the IoT is, we are understanding is like it is basically a network, right? So how I can just consider it, I can consider it like this. Like suppose this is a person, or suppose you can take an example of yourself only. So you are in a home and you see that bulb, tube light, refrigerators, even if we talk about your smart TV, your smart watch, they all are connected with each other and you can give it the command by using your mobile phone. So you are seeing like these all are in a network with each other in which you give the commands through your cell phone. So what is this? This is actually the IoT or Internet of Things. So it is describing like all the physical objects network which are embedded with sensors, software and other technology for the purpose of connecting and exchanging data with other devices and systems over the internet. So IoT is nothing but the network of physical objects which are embedded with sensors, software and other technology for the purpose of connecting and exchanging data with other devices and system over the internet. So this we have already discussed. Let's now go other, because I have just created a landmark where the important things are also marked in these notes so that you will not waste your time in your last minute of the revision time, and you will get these all notes in the description below. You can just go there and download it at free of cost. This kind of material is delivered to you by the SIN Education or SIN Education. Now let's see. IoT allows collection and sharing of data from a vast network of devices, and this actually creates an opportunity for more efficient and automated systems. Because when we talk about sharing, so there is one major problem, like suppose what I want to do. Suppose this is my mobile phone and I want to share the information through this mobile phone to lights, TV or smart watches. Then what is the thing? Then what thing will I be using? So I will be using an IoT technology for doing that. So the IoT actually help us in sharing the data over the vast network of devices, and this actually creates an opportunity for efficient automated system. Because you are sitting in Shimla and if you want to switch off your mobile phone or switch off your TV at which is going on at your office, let's take an example. Let's like in your office your reception TV is on and you want to just switch it off, then you can do it without coming in front of the TV by the use of your mobile phone, and it is a very easy thing, right? So that's how IoT works actually. In the coming years, IoT based technology will offer advanced level of services and practically change the way people living in the daily lives, as we are seeing it also. IoT is not just a system of interrelated things, but computing devices, mechanical and digital machines, objects, animals or people are provided with unique identifiers. Talking about some kind of a history of IoT. So in 1982, the vending machines was created. In 1990, toaster. 1999, IoT is come. 2000, LG Smart Fridge. All of us have used an LG in once in their life. So this is what it is. 2004 smartwatch, 2007 smart iPhone, 2009 car testing, and 2011 was the time of smart TV, which we are also using in our studios, and I hope that you are also using in your home. 2014 EcoDot, which was a very famous technology. 2015 Tesla Autopilot. You all know that these things are going on in the public demand today also. Talking about the components of IoT, then IoT comprises of devices or sensors, connectivity, data processing and an interface. So it contains majorly four things. First is are your devices, actuators or sensors, whatever you say, which takes the data from the environment or also gives some response in an environment. Connectivity, these all kind of sensors are actually or devices are connected together, and actually this network is actually called as IoT. First of all, it's a very important thing, and I hope that you also will understand. Data processing, the data which came through this network is also processed by using some sort of algorithms, either some sort of algorithms or any kind of a functionality. Through this data is actually get processed and then it is shown on your interface. Then these all four pillars are actually connected with each other. So talking about the components again, let's revise it in a quick fast way as possible. So first of all, the thing which comes in the scenario is devices or sensors. Then connectivity, these all devices are connected with each other. After that, data processing, because these all have data going through this network and there is some kind of a processing which is required here. And then this data processing is actually thrown away or shown on your interface which you use in your daily life. IoT is a network of interconnected computing devices which are embedded in everyday objects, enabling to send and receive data. We all know nowadays, like if I take an example of Google Smart Assistant, and so you will also see that it is also using an IoT based systems. When you talk about Google, when you talk about Amazon Echo Dot, then it is also a best piece or masterpiece of IoT. You use Google Assistant in your everyday life. How it works? They all work by using an IoT based systems. So more than this field, IoT is actually take this video as a podcast also, because you will understand that IoT demand is raising in a very great way as possible. All the companies including IBM, including Microsoft, including you can say a best example of this is Amazon. They all are using IoT based solution to give their life a best shot as possible. Clouds like this. So you will see that it is an immense thing going on in the market today. You are seeing that IoT is playing a major role. If you talk about things like Google Assistant or Gemini or any kind of smart assistant, then IoT is a place or a new future, you can understand in a way. So that's create actually make me also a motivated person to just learn about IoT and explore its way. You talk about Raspberry Pi, we talk about Arduino, we talk about a hell lot of things when it comes to IoT. So for that, for those people who don't know about IoT anything, this video is for you. Okay. Talking about the main components, or first of all, you read some sort of golden line which is written and underlined. So it means that it is a very important line. Let's talk about this, what this line is. So IoT is a network of interconnected computing devices which are embedded in everyday objects, enabling them to send or receive data. So what is basically happening? You can take a very simple example of a thing like a clock. Let's suppose a clock. Okay. So now clock is a normal object which actually works by using some sort of device or a battery in it. What happens or how we can make it an IoT based system? Simple sort of thing. You have to follow just four components. First, you will require a device or a sensor to take data. So what we want? The time data, correct? Time, temperature, any sort of data which is just measured by that particular device. And then we have to just send that data over the network which we will create. Then all this data will actually get connected. All this network is gonna connected with all the physical objects, and then data will travel through that network, and that network will collect the data and do some kind of a processing. Then you will require a processor for that. After that, after data processing, you will get a final result in the interface. So these were the four major components, and what I also want that you also take a full understanding of it, because it will create a great impact on your life and you will understand the IoT based systems. So more than this video, take it as a main learning podcast for you. Okay. Talking about the main components, so main components which you are seeing here is talk about the main component used. Then there is a low power embedded system which contains some kind of less battery consumption for high performance, right? So there can be this kind of things. So we want a embedded system which takes less battery and gives high performance. That's we are focusing on finding the components for our solution. Let's take an example like suppose I have to create an IoT device. Let's create that this boat is there. I have to create it as an IoT boat. Then what I will do? I will first of all find a solution for that, and we will find to figure out some kind of components. So when we're gonna go and find for the components, then we will find that components which will be best suited for us. So how we can do it? Simply, we will find a component which takes my battery in a less way and gives the performance in its bets. And so for that, we will just go out and we will find for the components which gives the less battery consumption and gives us the high performance. Just like we find a simple lights for studio lights, you can take an example for that. Talking about the next thing which you will require for building an IoT based solution is the sensors. We will focus more on sensors because different kind of data is available around. How you will measure a particular kind of a data? For measuring a data, we will require an enormous amount of sensors in our system, and for that particular systems we will create or we will just find the sensors in the market. So how we can find the sensor? Before that, let's understand what the sensor is. So sensor is actually a physical device. You can understand it in a way which used to measure. Let's give it a brief learning about that. So sensor is basically a physical device which measure and detect all kind of physical quantities, and then it actually gives signal, or you can say that it actually converts the signal. You can just see here, it detects and convert it into a signal. You will convert, you will actually get a data. Let's take an example. Let's take it as an example of a sensor. Like suppose this is a sensor, right? This is a sensor. What is happening? It is actually getting or collecting all kind of a data from a particular environment. Let's take it as a one end and second end is like this. Okay. So it is connecting or it is just taking away the data from the environment, and this side is actually releasing or the signals. This side is releasing the signals and this side is actually taking the data. Like this a particular sensor works. So I think now it's clear for you also like how a sensor is actually working in the environment. Now let's take an example of control units, because now the third system or the third thing which will be required for creating an best IoT based system is the control units. So talking about that, control units are basically the small computers which contains a microprocessor, a processing core, a memory, and a program input output devices. Now how we will just take it as, you can take it as an example of an Arduino Uno. I think you have all used Arduino in your once in the life. If you are in belonging to the field like electronics and communication, then you must know about Arduino. Or robotics, you will learn many things if you are in the first year and watching this podcast or video. So let's walk into the field of control units. So control units are the basically small computer device which is responsible for actually computing. So it actually contains one microprocessor, processing core, memory, and input output devices. Now input output devices contains the things like sensors, and also some sort of, when we talk about Raspberry Pi, then also the keyboard and mouse gets connected to it. So this is the thing: microprocessor, input output devices which are programmable input output devices, processing core, and memory. Memory for storing the things, processing for data processing, and integrated circuits are this actually termed as an integrated circuit. When you talk about integrated circuits, then these all take part together in it. So now I hope it's clear, pretty much clear to you also, that how it is working. Talking about the next thing, this thing we have already discussed. Now there are some sensors which are mentioned that you should know. Let's take a quick shot over that. Temperature sensors, image sensors, gyro sensors, RF sensors, IR sensors, MQ12/05 gas sensors, LDR sensors, and ultrasonic sensors. These are one of the most commonly used sensors in the market. You can take just a snapshot of it, and let's move to the next. Talking about the control units, we have already discussed about that. Cloud computing. When we talk about IoT, then it is incomplete without one particular term, which is the cloud computing. Talking about the cloud computing in bit detail, I will give you one incident, or I will take you to the one case study for understanding the incredible role of cloud computing in the field of IoT. So talking about that, you can understand in a way that cloud computing is actually a very vast space when we learn about that. Like, let's take an example of a farm. You have one farm. Let's take a farm here. You have one farm here, and actually what you want to do, you have to create a smart farm system. So what things you can do? You can track the moisture, you can track the behavior of the crops. You can just track the how the crops are getting weaker or stronger. You can even track about the energy consumption. There are many things when you talk about smart farmer things, because every time when you talk about farming kind of a thing, then it requires many kind of a sensors, because different farms are different. Like when you talk about rice, then there is a water which is there permanently. When you talk about the wheat farm, it is also completely different. So there are different kind of things which you can track. You can track about the raining patterns, you can track about the actually nitrogen fixation kind of a thing. So all kind of things are there when you talk about smart farm assistant. Then what you will require, you will require the sensors. Then the thing is, farmer is actually viewing the data from that phone. So how the data is coming to the phone, where it is getting processed, where it is getting segmented wise. Like if farmers is seeing in the form of a table in its regional language. So how this data is actually going to the farmer phone, it is actually going through the clouds. Very great, because how the data is going to the cloud even. So what is actually happening, that all particular devices or sensors which you have just thrown over that particular region, what it is happening, they actually collecting the data according to different sensors, different kinds of data gets collected, and then it is just send it to a cloud or a server. There the things get processed in the form, and then the data gets converted in the form of table, traditional rows and columns, and then it will be shown on the phones of the farmers. So like how actually the IoT system works when it comes about the smart farming assistant. You can take a best example of IPL. IPL is the best example of IoT. Any kind of a things, a single batted stroke also gets noted as a part of a data in IoT. In IPL also. In IPL you can see that the behavioral pattern of particular ball is also getting noted. So that all comes from sensor, but where it will getting processed? It is getting processed on the cloud. So like this you can understand this stuff in a very great way as possible. Talking about the things which I have just according to the simple ideology, then cloud is acting as a base for all kind of a data, and that farmer is also viewing the formations or data which is getting processed. After the processing, the data gets into a standard interface way, or in a standard interface UI, where a farmer gets full information about the farms and get to know many things about that, right? So like we can see, so the use of cloud, as I have already discussed, it's a reliable storage server for storing massive kind of a data. Then also the next thing which comes is the availability of big data. So like this is the very important stuff. Let's understand this. IoT works heavily on sensor data, as we have just discussed in that complete scenario, especially in real time. Massive IoT usage triggers massive flux of big data. Really true. Availability of big data, this thing we have already started talking about the network connection. Networking connection is also a very big part of IoT, because without network connection the data will eventually don't go into the network, into the server, and without data nothing will be processed and you will get nil. So how to do that? Like talking about the more detail about the networking connection, let's take a very great example as possible. So limited number of IP naming due to growing number of devices. This is a very major problem which are growing. As the number of devices are growing rapidly, the number of IP number is also getting, the naming of IP is also becoming very difficult. There are naming system which are more feasible. So like thing you can just see that in the networking concept there are many things which are involved, really getting affected because of all kind of stuff, and these things like networking and all plays a very crucial role as a pillars of IoT devices. Talking about the key characteristics of IoT, then you can just understand it by using this incredible short form. I hope you all will learn it, and this is my trick to understand this actually key characteristics of IoT, because it's become a very useless kind of a conversation if the main thing gets lost. So here talking about the key characteristics of IoT, then first thing is the connectivity stuff. IoT is useless without any kind of a connectivity, because without any sort of connection you can't assume a device which is working. Sensors and actuators. Sensors are important for collecting kind of a data, and actuators are responsible for motion. They actually converts the signals into a kind of a motion. Like talking about this thing, you can just take it as a sense like suppose there's sliding doors, automatic sliding doors you have seen in the markets, and nowadays everywhere in every kind of a big offices you are seeing that automatic sliding doors are used. So these are actually IoT based. That sliding motion which actually created by that particular system is done by using actuators, because they are actually converting that kind of a motion into that response, right? So like this you can understand it. Talking about the next thing, which is the data collection. Without data collection and its analysis, it's useless again. Then CSD is the short form for understanding this kind of three things. First of all, connectivity is must. Without connectivity, nothing will gonna work. You connect thousands of systems, but it will become useless for you to work. Talking about next thing is sensors and actuators. Without sensors, without actuators, nothing will happen. The data will also not get traced, and without that tracing, the thing which you want to do by using that IoT device, you will not able to do eventually. Data collection and analysis. Without collecting data and analyzing it, nothing you can give. Just raw data you can't deliver to your customer. You will have to deliver some kind of an essence or the best material to the customer so that it will get repeated. Talking about remote controlling and control and monitoring, then also an IoT plays a very pivotal role. Interoperability and security challenges are also the major point of things when it's come to IoT devices, because interoperability works like this, like all the devices should work in a synchronized way. All the devices should work in a synchronized way as possible so that it can create a massive kind of an impact on the customers. So these things without interoperability is nothing gonna work, right? Talking about remote controlling and control, like you are sitting in a Shimla and you are just controlling your home by just using your smart things app in your mobile phone, is made possible by using that remote control and monitoring. When it's talk about the security challenges, then IoT is what we say, like with every kind of a new generation thing, there are many challenges come. Like IoT also has many challenges, by the way. If we talk about the things like security challenges or security thefts, then the IoT is in a very top way, because IoT is a networks and any network can be hacked easily. It's a very famous, you can say famous words in the field of IT and IoT, like every network can be hacked. Anything which is on network can be hacked if the calculation and if your mathematics is strong. So again, security challenges are there, and IoT is a growing field, and as we know that 5G implementation in our world is also on a massive way. So IoT will increase in the future, and there will be many security challenges, but security policies will also be introduced in the world of IoT. Talking about next things, like this thing, I hope you all have understood, like I have talked about this. So there are some examples like smart home devices, we have already discussed in a case study part. Healthcare wearables, we are already using, like smart watches are nowadays getting popularized in a hell way. Like many companies are there. When you talk about the Pebble is also giving you the best smart watches. Boat is also providing that same. Samsung, Apple, even the companies like Digitech also is now going on for the smart solutions as well. So there are many companies are coming nowadays in the market which are providing the better IoT based solutions. You can see Philips is also giving the best or smart home appliances for you to use. LG was the first actually to just arrive into that kind of a market, like smart refrigerator systems and all. There are many things which are coming in the market, because it's a 22nd century, yeah, and many things will be coming. Don't worry. And talking about the impact of it, IoT made our life easy, very much easy. When you talk about the security part, you can just watch all kind of a camera by sitting on a room, turning off your iPad, and you can just watch away many kind of things in a very easy way. So how it is getting possible? It is getting possible by the impact or by the influence of internet based systems or IoT. Talking about one more thing which is famous is IoT. It's a very interesting stuff, like two I's are there. So it's not that much simple as IoT, but it is using one more time, which is industrial IoT. So here, when I talk about industrial IoT, it is some kind of an industry based solutions. For example, sensors on a manufacturing equipment that collect data for predictive maintenance and minimizing downtime. It's very important to minimize the downtime, because it will actually saves your time also, and also will give you the most of the best productions. Okay. So this thing is possible by IoT nowadays, because there you don't need to add more labels to your company to do kind of a stuffs. The IoT can easily do it for you. So this is the best things which we are also noticing like what is going on in the market right now. That IIoT is also getting very much famous. Connected cars are there, smart agriculture we have already discussed. This is the major design of IoT, like you can see it's a designing of IoT, like how you will design the IoT based system. So this is the device, this is the design part which is in front of you. Just take a quick shot over it, like how the designing part is going. So first you have to define the purpose and objective. It's a very important stuff. It's written here at the first. Like first you have to just design your objectives. Like, what is your role to use an IoT based system, because it's become very much popularized, right? Like, why you are designing it? Like, you are just wasting your time? No, you are designing it for a reason. So for that particular thing, IoT becomes very much important. Like any kind of thing, like if you are creating some kind of a projects, then also you will have to design something now. Without designing or without defining something like what you want to do, you can't do anything, right? Simple goes for the IoT. Device solutions and hardware design becomes a very important. Like device selection, you have to select a device. Now when you have decided your problem, now you have to go for the selection of device to do that. Like suppose I have the problem, let's take again a case study to understand it. Suppose I want to create that my studio should work on IoT, and I can easily control it by using my simple smartphone or smart things app, in which is there in Samsung. So how you will go for it? First of all, you have to define my problem, that I want to create the smart studio, correct? Second, what I will to do? Now I will go to the market and I will ask for the resources, for the selection of sensors, the actuators, or all kind of the networking devices or hardware devices, which I will be using for the setting up my device or the IoT system. Like the smart LEDs I gonna use. I gonna use smart you can say display systems, smart cameras, and there can be many lot of things. If you are going for like many amount of money you are having, accordingly you can just create your own system for that. Okay, so like go like this, you will just select for it, and then you will just go for the connectivity, like how your that all hardware devices will gonna connect. You will take a cloud interface for that. You will take a cloud infrastructure. Like nowadays there are many cloud infrastructure which are providing. Even the Blink Blink app is very much famous. Who are there in network and communication, they know the positive points of Blink app. Like Blink app is very much popular nowadays in the society. Many people are using the Blink app. Okay, so when we talk about this thing, then development stage testing is normally done on Blink. There is a Blink cloud is also there for IoT. IBM Watson is also there. Azure is there, AWS is there. There are many solutions which are there for IoT based systems. So like this you can understand. Then what you have to do, you have to go for data management and storage. Now when you got the connectivity done, your hardware devices is done, you are going very much great. You have just created an entire setup. Now you have to go for the software solution for data management and storage. There also the cloud helps. Security. After the data is with you, now you have a hell lot of data. You have to just keep it secure so that nothing or the third party can interfere on your data, and you can just your data gets leaked. So what the thing will be required is the security measures. The proper security measures will be required to work for that. User interface and experience, UI and UX. Like you are a technocrat person, right? I am a technocrat person, but suppose if I give this studio on rent, okay, then the personality who will be using that studio may not be a technocrat person like you and me. So what the thing gonna happen? He will not be able to control the devices. So he will require a very simple UI, so that he can make the use of it and just do the stuffs which we do in the studio. So the proper data manager UI UX experience will be required. Then interoperability thing, like all these things should be interoperable so that they can work together in an environment like this. Power management is important. Power management, because this all will not work on air. There will be a power source is required to work all kind of the solution. For that particular stuff, a proper power management is required in the solutions like this. So this becomes very much necessary for power setup. You have to set up a power based system, or the power network will be there. Spread across your studio, so that all devices should connect with each other and they can work easily, and then synergy with the main power system of your home, or you can say of a building, wherever you are setting your studio. So it depends, right? So power system will be required for that. Then scalability, like if in the future if you want to make this studio large one, then how you can use it to make how you can just introduce more devices to get connected over that. So scalability part is an important. Edge computing is an important part. Regulatory compliance is also important, and then testing and quality assurance is also important. When it call about the IoT based systems, then proper testing should be there. It's not like that you have just connected this thing, the things are coming on your phone and okay, you are good to go. No, you have to test it for 2 to 3 days, so that if any failures happen, you can easily fixing before moving it to the any kind of or providing any kind of a business services to anyone. So like this, the proper testing should be required if you are doing it in a first go. Otherwise, if you have an experience in this field, you are good to go with your solution. Okay, there is a simple stuff. Okay, just test and learn over the things. in a many way. Like when I was creating one project at my past in my first year of college, actually we are working on Flipkart robotic project, which was under the Flipkart robotic grid 3.0. Like many people have heard about Flipkart grid. Okay, it's just like that. So what we were doing, actually we are actually creating a solution for delivery bot system. So what happened, we struggled 4 months to work on the robotic system, because we are actually not having any kind of a knowledge related to robotics. So and just we have just jumped into that, and we also trying to to try to learn something from that. So at that particular time we learned many things, guys. We have learned many things. Okay, so let's take a quick shot over that so that we can understand the more technicalities of this particular problem. So talking about the agriculture IoT case study, so I will take a quick shot over it because this thing we have already covered before also in this podcast. So let's talk about next thing. So more than this learning video, you are just seeing it as a podcast, if I'm not wrong, because we are just sharing the stuffs with you. Talking about the next thing, the objective of this particular things majorly are three: crop yield, quality, optimize resource usage, including water and fertilizers, monitor environmental condition for better decision making, device selection. Again, these things are happening. So I think it's all clear. Okay, we have all thing which is important is decision support system, like the what this is. So decision support system is basically implementing an intelligence decision support system which actually used to process the collected data to provide personalized recommendation to the farmers. Okay, it include optimal irrigation schedule, soil moisture level, and weather forecast. This thing also we have just done. Automation, like actuators, the thing of actuators actually came here. We have already discussed that automated irrigation system should be there, and the moisture sensors you can use for that. It's a very good and easy way to do it. So like this you can just understand the things, like how these things are going on in the market. Talking about the results, you will get a good crop yield, resource efficiency will be there, real-time monitoring, scalability, positive feedback will be there. So talking about next thing is which is the physical device for IoT design. IoT design. What are the physical device? So again, the first thing will be the form factor. Like many people don't know about that, what this thing is. So it is actually for form factor is actually for the sensors which you will be using. Okay, it can be the sensor shape, size, and monitoring capabilities, enclosures and durability, power supply, power requirement designs. These all are actually in the physical design. Like talking about one and one in detail, let's go. Form factor. So whichever design whichever system or device you are using in your IoT system, you should go for considering its shape, size, and monitoring options. Talking about enclosures and durability, like the working durability of that stuff, like how this thing gonna work and till how much time it will work. Like suppose if I brought some kind of a sensor, then I should know that how or you can say when we bring a tube light, what you see, like how much hours it gonna work for getting degraded. Like if you are using a tube light once in your life, or if you are just taking or just buying one tube light, then you have this keeping in the mind na, like when it gonna get damaged. If we talk about the systems like engine oil also, so you get a particular amount of kilometers, right? Like that after that kilometers you will have to change. So till now we have studied these things like enclosure and durability in big detail, but when you talk about power supply, without any efficient power supply, your IoT system will not gonna work like this, like the thing like it should work. The IoT will not work like that. So for that particular thing to set up this, we will require an efficient power supply or power requirement or power supply map, so that we can follow a particular power supply map and we can deliver the best service possible. So I think you can understand this stuff. Okay, talking about the connectivity modules, because now you have a efficient power supply, you have done with durability and enclosure thing, you have done with all kind of stuffs related to the sensor design, shape and size. Now the thing which comes here is the connectivity modules. You will require a proper module of connection so that you can connect all kind of devices. For that particular thing, you will require an integrated suitable communication modules which will consider the things like range, bandwidth, power consumptions and all. Sensors and actuators are definitely a part of it. PCB design will be there, modularity, security features, environmental sensor, and now this thing will go on. Okay, so the major things I have just covered. This thing will also take place when we talk about designing a physical design. Then the stuffs like reliability, deployment strategy, this all will come, because this will require these features are actually related to the physical stuffs like the security thing, like any kind of a bug is also not there, so it is actually tracking your activity of users, right? it can be the deployment strategy, like how you're going to deploy these devices in your home and how you will going to work for that. So like this all stuffs are there. Okay, so that you can also prefer of understanding it in a well way. So these are all in a very brief way, you can just go and read it once. Now the thing comes is a logical design. We have discussed about the basic components first, then we have just designing, we have just seen of IoT system, then we've seen now physical device. Now we will see the logical device. So talking about the logical design majorly focus on the software architecture, communication protocols and data processing mechanisms. These were the fields of interest when we talk about the logical design system. So this is how the logical design actually looks like. So it contains communication protocol, because as we have seen, the software architecture, communication protocol and data processing mechanism, these three things will be there. Firstly, software architecture will be there. Second, communication protocols will be there for sure, and then the data processing elements or mechanisms will be there. Software architecture, communication protocol and data processing mechanism. Again I want to repeat, software architecture, data processing mechanism, communication protocol. You can just think it as a way like software architecture is necessary for actually processing data, and then you will communicate. So like this, in a short hack way you can understand the thing. How, again I will gonna repeat, software architecture will actually do the data processing and then you will gonna communicate it, and for that particular communication you will require communication protocols to that. So this is the thing. So this is the logical design of a system. Communication protocols, data processing at the edge, device to cloud connectivity, firmware and software architecture, security features, over the air updates, sensor data processing, device management integrated with cloud services, interoperability, edge analysis, user interface and interaction, and data storage and management. So communication protocol will be considered under the logical design. Data processing at the edge, like how the data is getting processed. Device to cloud connectivity, like this, all kind of an hardware devices or sensors which you are using in your system are connected with the cloud. We will study that. Firmware and software architecture, like how your architecture is actually designed to, this kind of thing will be there. So integrated with cloud services, that's the thing, like we will have to integrate with the cloud services. Without integrating with the cloud services, will be able to work here. Okay, sensor data processing, like how your sensors are processing your data. Device management, how you are managing your devices actually, in like how then you are integrating it with the cloud services. Interoperability, like how these all devices are interoperability gonna work, how this is gonna work together. Edge analytics, like how the data is getting processed and analytics of that complete data will be given. User interface and interaction, data storage and management will be there. So these all stuff will come under the logical design when you talk about computer architecture and stuff like that. Talking about this thing which is over the air updates, it is actually like if you are out of a state, then again you are also seeing all kind of analytics on your phone and you can easily take a good understanding over that. For that particular thing, the over the air kind of that complete scenario is introduced actually. So this is the thing, it's in bit detail is mentioned over here. You can just give a go through over it. What I have explained, this is all is mentioned here. So you can, like here you can see, this is the actually short trick to understand this all kind of stuff. CDDF, SOS, SD, IT, EDU. Let's understand this. As CDDF means, CDD stands for communication protocol, C, data processing at the edge, D, device to cloud connectivity. CDD is complete. What it is? Communication protocol, data processing and at the edge, device to cloud connectivity, CDD. Data processing, communication protocol, data processing at the edge and device to cloud connectivity. CDD. F stands for firmware and software architecture, security feature, over the air update and sensor data processing. FSOS, then it is device management, integration with the cloud, interoperability. Again, so what it is? It is simple mnemonic which you can remember. FSOS DI, like this. FSOS DII. FSOS stands for firmware and software architecture, security features, over the air updates, sensor data processing, device management, integration with the clouds, interoperability. Then talking about EDU, edge analytics stands for E, data storage and management stands for D, and user interface and interaction stands for U. So it's an FSOSII, and it is next then edu. Like this, by using this memory, I think you have understood this, you can understand this complete answer. Talking about functional blocks, so what are functional blocks first of all? So functional blocks are referred to as a distinct units or components within a system, each responsible for carrying out a particular task or a function. So you can just understand a function block as a block which is responsible for doing a particular task which is allotted to that particular block. It will just execute that particular task and that's done. That's the function blocks. Okay, now I think you have understood this. So this thing you have already studied. Talking about explanation again, then it contains modularity, interconnectivity, abstraction, encapsulation, reusability, testing and debugging, scalability. So this is actually the explanation of functional blocks in detail. So what is the functional blocks look like? It stands for modularity of a system. Clear responsibility is given to that particular functional blocks. Interconnectivity is there in the functional blocks. Abstraction is there. Encapsulation is there. Reusability is there. Testing and debugging and scalability is there. So you can take it as a 3-3 pair and you can just learn like this. You can take an example of 3-3 pair here, like take the 3 this: modularity, clear responsibility and interconnectivity. Again, modularity will be there. Responsibility will be very much clear, and all these are interconnected with each other. So interconnectivity will be there. Abstraction, encapsulation and reusability. Abstraction, what we do in it, we just hide the unnecessary information from the user. Encapsulation, we combine the data with the functionality. Reusability, we make it in a reusable form. Testing and debugging is also there, where we test a particular thing. And scalability, to scale a particular thing. This thing happens in functional blocks. So this is the proper explanation of functional blocks, how they looks like. So this thing is pretty much clear. You can just give it a shot of understanding. It's very much simple. So example functional block is just given here. How a particular function block look in an IoT system. It is actually important because this is going to help the actual working of it. This is going to help to understand how this actually IoT system is getting worked. So first block is the sensor block, which actually responsible for collecting data from the sensors. This thing is there in the sensor block. We collect the data from our physical environment. Then through the communication block, that entire data gets traveled in the network. Then cloud services block, actually this data gets stored away in the cloud. Then after that, user interface block, which is used to monitor and control that data which is provided. Then device management block actually manages the devices, right? And then security blocks actually help to create a security layer over that complete network so that nobody can enter into it. Then actuator blocks actually do the performance according to that data. Like if a personality is standing in front of a sliding door, automatic sliding door, then it will actually sense that data that someone is there, and then that actuators will help the motion of opening the door. So this completely happened by using this function block. So what is happening? Sensor block is there to get the data from the environment. Communication block is there to just go for a network, and can this particular data is circulated over that network. Then cloud service block is actually responsible for storing that data on a way, and then the user interface block is actually responsible for providing the data on the UI, and then device management block is actually helps to monitor and manages and all kind of health status and configuration of individual device. Then security block actually implements all kind of that security measures on that complete system. Then actuator blocks, what it do? It actually do the processing or do the things as an output by using that data, like automatic sliding door. I just taken the example of it. Talking about the much more detailed things like communication model. So communication model you can just understand in a way like in context to the information systems, network describe actually the flow of information between the different components or entities. So that flow of information among the different entities is maintained by that communication blocks. So let's understand about the communication models. So there is one simplex communication in which the data flows into the one direction only. Talking about the half duplex, in which the data flows in both the direction. Talking about full duplex communication, in which the data flow from sender to receiver or receiver to sender simultaneously. Like this it happens. So what in the simplex communication, the data flows in one direction from sender to receiver. In half duplex communication, the data flows in both the direction. The full duplex communication, data flow in both the dimensional simultaneously, but in the half duplex, the data flows in both the direction but not simultaneously. But in full duplex, the data flows full simultaneously. Point to point communication is there, where data is exchanged between two devices. This is all from the communication models. Now I think you got a complete understanding. In the simplex model, the data is flowing in one direction. In the half duplex, the data is flowing among the two directions, but the thing which is maintained here is that it is not going simultaneously, but in the full duplex communication, the data flowing in two direction but simultaneously. But point to point communication, the complete data exchange is taking place between the two devices at a point in time. So this is the thing, or the complete. Next thing is the communication model, which is the broadcast communication. It involves one sender transmitting data to multiple receivers. You can just take an example of a TV here, like how the signals is getting actually received on your TV. One particular tower actually sends the signals, and that particular satellite which is there on your terrace, it will actually receive that, and the things gonna happen there. So that all is done by using this broadcasting communication model, and that's why you have just seen that in many TV shows they will use, they have coined the term like broadcasting, like today we are broadcasting this movie. What this thing means, the movie will be played on one particular thing, and from that particular space the data is gonna just send it over to the different servers, and that particular servers or satellites or receivers will actually receive that data, and they're gonna show you on the print. Like this, there is one multicast communication will also there. So it's a hybrid model of point to point and broadcast. What it means, broadcast capabilities of sending in data to the multiple receivers, and point to point means you can just select the receivers to send. Like you can send at a time, you can send to multiple receivers, okay, but on the selected receiver, these receivers you can also select. So this is a multitask communication. There is one client to servers model, which is used to send the request to the server, and then server respond to this request back. It is actually API working, right? Application programming interface. If you are familiar with the technocratic terms, then API you have just heard of it. Like suppose you are using one Netflix, so how the data is actually working in the Netflix, from where the all kind of movie or TV series are synchronized on that particular app. So it is actually happening through the APIs. API actually do the sending and receiving of data kind of a thing. Like if you are logging your details, then it is actually sending your credentials to the server for verification. And from there, if your verification comes, then you will get an entry into that app. And after getting entry, you can just access to all kind of a contents which is stored in the data collection or in the server of Netflix. And from that, you can just access to all kind of movies and web series. This is how the simple working principle of API works. It's just like a waiter in the restaurant, just taking your orders and bringing you the stuffs on meals to you. So this all stuffs are maintained or done by the API. So nowadays the APIs are developing at a rapid pace for you. If you want to listen to the music, then there's a Shazam API is there, where you can just receive any kind of a music. If you are creating any kind of API, you want the Google location, the best Google API is also provided by Google. So there are many kind of API nowadays which are coming in the market, and from that you can just learn something, right? Peer-to-peer communication, you are not directly communicating with each other without control server. Here what you are doing, simply you are just directing communicating with each other. Peer-to-peer means my friends circle or a circle through which you talk actually. So peer-to-peer communication is a kind of a communication where you are just communicating directly with your peer, okay, without any without any control server. Talking about message passing communication, so here what is happening, you are sending discrete messaging within the processes. Like suppose there is one process is going on, and I want to inform that this process has been complete to the another process, so that another process can start its working. So for that we will use the message passing communication. So this is also a part of a communication. Publish subscribe communication is also there, where publisher sends messages to all its subscriber initiated the interested in that event. Like you can understand it as a notification of your video on YouTube. Like when you hit on that bell icon, I know you don't have subscribed my channel, just subscribe it first, and just subscribe it first and share it with your friends, and all they can also get the knowledge of IoT through this video. So what is happening when publisher is sending message to all its subscriber that a new video is released, or a new kind of stuff or new product is released for you all. So what you gonna do, just go there and watch this video or watch that product and just buy it, okay. So like this thing happen. IPC is there. It is studied in operating systems to be precise. So IPC stands for inter-process communication system, where two or three processes are communicating with each other through a mechanism, and this mechanism can be the shared memory one, message passing, or remote procedure call. So it is actually the IPC is a very important point of contact, or when you talk about the systems calling or the things like operating system, then IPC becomes very main, because all kind of processing in your computer system is actually working through a communication thing. Like one processor or one transistor is informing other that I have done my job. So that particular communication, like suppose you are running 2 to 3 applications on your system, that all are run by IPC or inter-process communication. Without that, the working can't be there. There are one more thing, which is communication API. They are used to facilitate the communication and interaction between different software application or services. Very easy definition. Suppose there is one service 1, there is a service 2, you have to communicate with each other, then there is a communication API, right, to take your job. Done. So here are some common examples. Telephony API is there. Like Twilio offers voice and video calls, messaging, phone number management. Like the OTP part is there now when you log in into the WhatsApp and all, the Twilio is going to maintain that. Nexmo sends for SMS, same like Twilio. Chat API is there, like PubNab, Sendbird, which sends multiple messages together to for one time, like WhatsApp marketing and all stuff are there na. There the things come like this. Video conferencing API, Zoom is there, Agora is there, one more is there, I will not actually getting the name, but they also offer video conferencing services. Email API is there to send the email. Social media API is there. The web RTC APIs are there, which are they actually provide real-time communication over the web, including voice and video calling. Like this is also there. Push notification APIs are there. Like suppose you in the app there you want to do a particular notification for your customer, like this new feature is there in the app, so you just update your app. That kind of all kind of push notification which you see on a notification bar na, on your mobile phone. These all are done by using push notifications API. One Signal, Firebase, Cloud Serve. Many apps are now nowadays using Firebase also. So for that particular thing, push notifications is there. Voice recognition and speech API is also there, where you can recognize and voice and work over that. Cloud, Google Cloud speech to text is there. Microsoft Azure speech. Unified communication like Microsoft Teams, Cisco WebEx is there. Payment gateway API is there. Stripe, PayPal, IoT communication API is there. There are millions of APIs developed. According to your use, you can just select any one of it. Okay, so it is just a thing for IoT communication API. These all are the API name. So you can just see this, and this actually are the protocol stuffs. Like for the API to work, you will require a certain protocol, right? So what kind of protocol is there? So first of all, there is a message queuing telemetry transport is there. Protocol designed for lightweight and low bandwidth and high latency. Constrained application protocol is there. HTTP protocol, advanced messaging protocol, data distribution services, extensible messaging and presence control protocol, Microsoft Azure, Google IoT API is there. So all kind of protocols are mentioned, right? Talking about that message queuing telemetry transport protocol, so what it is doing? So it is responsible for lightweight and efficient publish and subscribe messaging protocol designed for low bandwidth, high latency and unreliable networks. COP is a constrained application protocol, which is a RESTful protocol designed for resource constrained devices. You have to just learn about that coin terms, right? What are the resource constraint? Like some kind of a resources are constrained in that device, like you can't use camera or any kind of things. HTTP and REST API are widely used for their simplicity and compatibility with existing web technologies. Advanced messaging queuing protocol supports reliable and secure communication between devices and IoT platforms. Data distribution services is a middle and standard that enables the data-centric communication between the distributed systems, including IoT. Extensible messaging and presence protocol. This is originally designed for instant messaging, right? Talking about IoT Hub APIs or Microsoft Azure for bidirectional communication between IoT application and devices it manages. It supposes MQTT, AMQP and HTTP protocols together. So you can see that when you are just moving towards the clouds and you are learning about so much about that protocols, right? Because without protocols the security can't be maintained, and without proper security you can't leave one IoT system like that, because there will be many kind of trespasses, right? Like when I was Smaller, I gonna use the WPA tester kind of thing, which can easily hack anybody's Wi-Fi. But the condition is the device should be rooted. So like this, the network can be easily be hacked without any proper protocol for sending and receiving. These APIs can send your information anywhere, and you don't even know that your phone microphone is on and your information is going in that complete night. So like this, the thing is happening, right? That's AWS, Google Cloud, LA Join. There are many kind of protocols. Talking about IoT enabled technology, smart sensor, we have already discussed. Radio frequency identification, using radio waves to identify or track objects, RFID. NFC is a short range wireless communication between devices, contactless payment, like in the phones like Apple iPhone and majorly S series of Samsung, they actually support NFC, right? My phone is also supporting NFC. Like when you go to the foreign and when you go to the UK and US where the stores have the NFC scanners, you have to just tap your phone and the payment will be done, like kind of things. Embedded systems like Arduino, smart actuators like physical actions like smart locks, smart motors, smart systems, smart doors, that kind of things come into smart actuators. Embedded system like Arduino Raspberry Pi is there. Edge computing involves processing data closer to the source, reducing latency and bandwidth uses. Now what is happening, we are just processing the data which is very much nearer to the source. Suppose you can take an example of a thing like, suppose you have to scan a particular data which is near to you, like you have to scan my hand, like my hand is there. So for that particular near range, don't use any cloud for processing. Instead you can use my mobile phone for that particular processing. But when the data is in abundance, you will go for the cloud, right? So when the small kind of thing is available to you, so at that particular time, what the thing gonna happen, you gonna use the edge computing, like the device which is closer to you, we will use that for processing stuffs like this. Talking about power wide area network, LPWAN technologies, they provide long range communication with low power consumption. Like suppose I want to communicate for the device which is far away from my distance, so for that particular stuff I will be using LPWAN. IoT platforms are readily designed nowadays for just communicating stuff. Machine learning AI is there, like IoT is actually integrated with them to work together, like data processing stuffs. For that particular thing, machine learning is used, like they actually convert that data into predictive analysis of that data. For that thing, AI and machine learning tools are used also. Augmented reality and virtual reality is the biggest example. Blockchain is also an example for providing secure and decentralized method of recording. 5G networks, they are also a big part of IoT because nowadays 5G is going in a rapid way. Talking about wireless sensor networks, so for that particular thing, what are these kind of sensors? They are, like let's talk about wireless sensor network. So wireless sensor network is a network of specially distributed autonomous sensors that communicate with each other wirelessly to monitor physical and environmental conditions. So it is actually a network of a kind of sensors. It is first of all a network, but this network consists of the sensors which are connected with each other wirelessly, and they are actually monitoring the environmental and physical conditions. So this thing is happening. So this is a network of wireless servers which are connected to sensors which is actually monitoring physical and environmental conditions. This is how the wireless sensor network actually works. Just break these words, you will get your answer. Easy, right? So these were the things, like sensor nodes are there, communication protocol, wireless connectivity, gateway, power management data. These all are the things which are there. A simple complicated IoT network is there, like this thing only, this particular thing is designed. You can take a quick shot because it will be very easy to understand, right? So this thing is there. Gateway, just understand this thing, what is gateway. I will just coin some kind of important terms because you can just read it out, it's very easy to understand. Gateway or sink. So it is actually the central point where all data will come from sensor or nodes. This is the gateway or sink called. Security measures, like the thing which are developed or the measures which are developed in a sensor show that the things like data tampering and EOS dropping don't take place, right? Self-healing should be there. Changes in the network such as node failures or changes in the environment shouldn't be there actually. Cloud computing is actually delivering of computing services including computing, storage, databases, network analytics over the internet. This is the cloud computing. I have actually discussed it before also, right? So you can just take a look, like there are different service model. IaaS, platform as a service, software as a service. Infrastructure service is actually giving you the information or resources over the internet. Platform as the service is actually giving you the platform for doing the stuffs like that, okay? And the software as a service is actually providing you to the some kind of basic created software for you so that you can process data easily. It is actually providing you the complete software for analysis, but platform is only giving you the platform, okay, where you can just run and manage your application. And infrastructure is actually only giving you some kind of servers to just run your application. Platform allow you to develop and run application. They give you the accessibility to run and develop your own. Deployment models are three: public, private, hybrid. In the public, the third party will also be with you. In the private, you get a proper private cloud, the private infrastructure, or you can just get your private space to work on your data so that all kind of security should be maintained. Hybrid cloud contain both the part of private and public. According to your need, you can just do the stuffs between them. Okay, on essential basis, the services like on-demand self-service, broad network access, resource pooling, rapid elasticity, these were the essential characteristics of a cloud computing. Like whenever you want the resource boost, you will get a resource boost by paying some extra, as pay as you go. The very popular line on cloud computing is pay as you go. As you require, you can just buy the things or resources, right? Like this thing, it has happened. And benefits of it: cost efficient, you don't have to install a complete hardware. Accessibility, you can access it from worldwide. Security is also maintained, they will be maintained by a cloud service. You don't have to take any hectic job of maintaining security protocols. Flexibility and agility, whenever you need it, you can just add on the resources. If you don't need, you can just reduce to save your cost. Scalability, you can easily scale up your resources according to your need. Suppose I want to host one webinar and there will be millions and millions of followers of mine will be attending soon. Let's hope for the best. So for that particular thing, I will be requiring a lots and lots of resources so that my resource or my website can be managed. For that thing, I will need it, I will pay extra, they will give me the more resources. So like this thing that you can do it. Challenges are security concerns because you don't have the full control over that. Compliance and legal issues, there there is a standard compliance or regulations which you have to follow. Limited customization, as I say, you have to follow a standard guidelines. Dependency on internet connectivity. Suppose on a way where you don't get a proper internet connection, you can't access your device or network or the infrastructure, right? There is one more thing which we learn about big data analytics, which refers to the process of examining and extracting meaningful insight from large and complex data sets. When you have large and complex data sets at that particular time, you require a proper understanding of it, where the big data analytics come into the play. So here there are the 4 V's of big data. Let's take a quick shot over that. Volume. Volume refers to the sheer size of data which is generated or collected and processed. You have a very good volume of data. Velocity, which actually describes the speed at which the data is generated or collected. Variety, you will have the different kind of variety of data. Versatility indicates the reliability and accuracy of the data. There will be 4: volume, velocity, the speed; variety, different kinds of data; veracity, the reliability and accuracy of data. These were the 4 V's of that big data which you can understand, right? Now data can be structured, unstructured, semi-structured, depending on completely on you. And platform like Hadoop, Spark and Flink frameworks can be used by you if you are working on data processing kind of stuff. When you talk about the data analysis, then you can use these stuffs like descriptive analysis, predictive analysis, pre-descriptive analysis and machine learning stuff. Charts and graphs, dashboards, this all you can use for representing your complete data. Embedded systems, if you talk about embedded systems, then the specialized computer system which are dedicated to do some kind of functions within the largest, because you suppose you have a large system and you have to do a particular stuff, because when you talk about IoT, you will require some kind of different processing, right? So for that particular different processing, you will require different system for processing. For that thing, the embedded systems come into play. So these are the actually specialized computer system which are specialized to do particular task and perform dedicated functions on task. Okay. So these were the thing which I think you can understand. They include microprocessor, controller, memory, input output, real-time clock which provide timekeeping in the application, power supply is there, characteristic of embedded dedicated functionality, real-time operation, resource constraint, reliability and integration. And applications is there like automation system, industrial automation, any kind of automation. Nowadays IoT is everywhere, okay. So these all are the application of it. Major complexities are complexity, like anybody can't understand the working of it. Power consumption, security and software updates are the major challenges. But I hope you all get understood regarding that. So now let's talk about some very crazy stuff which is IoT Reference Architecture. So what this actually term means when we talk about the things like IoT, then what this reference architecture is referred to here. So it is a very fundamental concept of IoT. Like till now we have discussed about embedded systems, and also we discuss like how IoT actually works. So now we will discuss like IoT reference architecture. So how it looks like, it's very much simple to be understood. So let's take a quick shot over that. IoT applications, first of all, what happens? First of all, there will be a layer, of device, sensors and actuators will be present. On that particular thing, what next thing you will be having is the IoT network. The IoT network will be there, and on that network there will be IoT management service platform and then IoT applications. So how it is going on? First of all, you are having some kind of sensors or actuators. Why this is important? Because sensor will actually take the data, actuators will actually convert the data which is coming from that processor into a motion, right? Then a network. After getting over to the layer of sensors and actuators, what you will require to create a network of that. So that particular thing is referred to as IoT network. After that, after the network sort of things, what next thing you are going to do is the management service platform, or the platform where you will manage all kind of the services. So this kind of thing will happen, and then after that you will go to the IoT applications. So first sensors and actuators, then network, then management service platform where you can manage all kind of IoT services, and then on top of that you will having the IoT applications working. So this is just a simple level of working. So there are certain levels on which our IoT systems works. So here let's understand this level. First level is IoT application device level, where all the physical IoT devices are present. Then we are having IoT network level is there, and on top of that we are having IoT application or platform level, and after that we are having IoT application level. So what was the first level? First level is for IoT device level, where your all kind of physical IoT devices are present. And after that there is a second level also, which is IoT network level, which is also termed as level 2. And after that we are having IoT application services platform level, where all kind of key management software functions take place. And after that we are having IoT application level, which is the level 4, where all applications will be present, just like this thing which we have just understood. This is the first level of device and sensors and actuators, second level is of network, third is of management service platform, and on top of that we are having all kind of IoT applications working. So it is basic reference architecture of IoT. So talking about the IoT device level, I just talked that earlier also, that all kind of sensors and actuators are present. Let's take an example of this smart studio. So here the devices or sensors, cameras and all kind of things which are collecting data from the environment, things kind of like these things are actually present over there. And after that IoT device level, we are having one more level, which is the IoT network level. It compasses all kind of a network facility which is present, and it is essential for communicating between the IoT devices. After that we are having components or IoT gateways, routers, which are present in the network. When it comes to IoT application service platform level, there the key management software functions are there, where you will gonna manage the data or the reference of that data in a very easy way as possible. So it's basically an IoT service platform level. After that we are having IoT application level, which is the toppest level, and on that it consists of all kind of applications which are operating within that IoT network. So it is a basic hierarchy of or the reference architecture of IoT, right? Now when we talk about the deployment models, so IoT contains different kinds of deployment levels. When without deployment your work will not be complete, it will be incomplete. If you will just create one solution and just keep it in the cupboard or wardrobe, then it will just remain wastage of your time. So talking about the deployment levels, then first thing is the device deployment, where you are just gonna deploy the device, communication network deployment level. Then edge and fog computing deployment level, where all kind of edge and fog computing things will be there. Then cloud computing and IoT platform deployment level, where all kind of cloud computing and IoT things will be deployed. Then we will be having application deployment level, then data analytics and insights deployment level, then maintenance and monitoring level, then security and compliance deployment level. So these are the basic deployment models which are present in the IoT. Now talking about bit of them in detail, like device deployment involves physical deployment of IoT devices such as hardware, actuators, sensors in the environment. Talking about the communication network deployment model, so it consists of communication network infrastructure that facilitates data exchange between two IoT devices. Suppose you can just understand in a way like there are 2 or more sensors which is installed in that studio. Now all these sensors are communicating with each other through communication network deployment level, where all these sensors are communicating with each other, and accordingly they are doing their functions. So these are actually your communication network deployment level. Talking about edge and fog computing deployment level. So in this particular thing, we will be utilizing edge and FOG or fog computing resources to process data closer to the source, reducing latency and optimizing bandwidth usage. So it is basically an edge and fog computing deployment level. Talking about cloud computing and IoT deployment level. So deployment of cloud-based services and IoT platform for centralized data storage, analysis and management, because what happens, like all kind of data which is collected from this particular network will actually go to the cloud, and there all kind of services you will avail by the cloud service provider or your CSP. So that particular sting where you will be stuck there, so there your cloud computing and IoT services will be provided. So for that particular service deployment, we are having certain cloud computing and IoT platform deployment models of working or levels. Talking about application, now being a user, you are a user, I am a user, I just want to perform some kind of a task. So I will not go completely detail into how cloud gonna work, how this management will actually take place. I will instead use one application to do my tasks or day-to-day tasks. So simple and salted thing is like very much easy thing. Like you will be using one kind of an UI based application to do your task, or just do giving your commands to an IoT device. You will not go to the particular cloud service provider dashboard and give the commands. You will give the commands to your application. So that particular thing is an application deployment. It involves a massive usage of UI in it. Okay. Talking about data analytics and insight deployment level, so that all data which will be processed on that cloud will be thrown away on your app, and you will just see this actually data on your mobile phone easily, right? So that particular complete stuff which will be happening is the data analytics and insight deployment levels. Okay, I think it's understandable. Now the maintenance and monitoring level, what you will be doing, you will be maintaining and monitoring all kind of things like the systems which is ongoing maintenance and management of entire IoT ecosystem, because your application is running fine, no problem, but over the time the things get updated, so you will require a continuous management system to work upon your application so that the user gets the better experience, and it can also reduce the latency kind of a thing, because as a developer you also know when you talk about a technology like React.js, so there you even know like the things gonna happen is very much easy. Like suppose on 1 month we are working on one technology, and after 1 month it will get updated, so that apps which will be using that technology and you have just deployed it over Netlify, over any kind of web seller, any kind of the net deployment models, if you have deployed your application, if you are not checking it regularly for your as a kind of a maintenance, then what's going to happen, like over the time the tech stack get outdated and the services will be stopped and your app will gonna crash. So to avoid that kind of failures in your system, what gonna think, you will have to maintain one model which can maintain and monitoring your IoT system. Talking about security and compliance deployment, like without security your model will not be successful, so you will require a proper security measure to just work upon it. Okay, so that particular thing will be delivered by this thing, and it gonna involve a massive usage of protocols, right? So to that particular thing or extent we are just going for the IoT. So security and compliance deployment level is very much important. Without that it will be much difficult for you to understand the stuff. So talking about more things in IoT, so talking about more things, it involves things like sensing and addressing and unique address, ability to communicate with the network. Like all the sensors and actuators are present and they are just communicating with each other, and you are just getting all kinds of control. Like if you want to switch off the light, you will just switch off the light. Okay, if you want to, if you got some kind of a notification and you want to work upon that, so this is also can be easily possible by using IoT. IoT hardware and software. First is sensors and actuators. We already learned about this, so I will not go much in detail. So what it contains, basic sensor, like it contains one, and it takes the physical signal from the environment. Then there is one sensing element which is responsible for the data collection. Then microcontroller will be there for data processing stuff. Then transceiver actually used for data transmission from one particular sensor to another sensor or to the cloud, right? So it actually gives the electric signal to the IoT gateway. From that particular stuff, the data gonna go to different kinds of cloud service providers. If you're using one CSP, then it will go to CSP. From that particular thing through broadcast network, it will be flash over to all kind of dashboards by using the API. So like this, a particular process goes. First, the data collection take place, then data processing will be there, then data transmission will be there. So this all kind of things gonna happen in a very great way. There are much more sensors, like there's a temperature sensor where we just want to use the sense the heat energy or coldness from the system or the physical thing. So it involves thermocouple, it involves resistance temperature detector, it involves thermistors, and it requires the semiconductor and also an integrated circuit which can operate over the adverse temperature condition, because it is very important, because like many sensor devices or smartwatches were used by the mountaineers or climbers are very advanced from the one which we are using right now. So why this is because they are just exposed to the adverse weather conditions. So at that particular stage it becomes very difficult for them to survive. And so that particular stuff, like according to viewing the different nature or the practicality of the problem, the system is going to develop. So it is the very basic example of how the temperature sensor works. Talking about next thing are the pressure sensors. So they are used to just measure the pressure of a gas, including water level, flow, speed and altitude. So for that particular stuff, the pressure sensor is gonna use. So how you can understand, like there is one submarine you have to develop. So on that particular stuff, you will require the pressure sensor to just measure the pressure of the water which is coming over that submarine when it is just going underwater. Like many people say, like 11 elephants weight is there on a submarine when it actually travels through the water. So it is a very tough job. So that particular thing, the pressure sensors take the job for you. Okay, so like this thing you can just see, the touch screen is a pressure sensor, so according to your pressure it's gonna work. So these were the basic examples. Talking about the humidity sensors, they are used for using humidity or measurement of any kind of moisture content in the thing. Talking about the major things like integration with IoT, like smart home devices, data logging and many kind of applications are there. Nowadays IoT is in everything, right? Like talking about from the manufacturing, starting from the manufacturing to the smart home appliances to the smart studios. The IoT is everywhere. Nowadays everything like electrical appliances were also developed by taking the IoT part into consideration, so that you can also work remotely, because IoT is much more important thing to work remotely, right? For that particular concept, that complete IoT system is gonna develop. So this thing I think you can easily understand. So talking about ultrasonic sensors, so they basically are used to measure they actually use the ultrasonic waves for detecting the distance and presence of the objects in their vicinity or from their surroundings. They are actually just detecting like any kind of an ultrasonic waves which is coming. So they're gonna measure this thing. This thing will be measured by the ultrasonic sensors which is present in your vicinity or in your surroundings, and accordingly it's gonna work. So working principle is that they work on high frequency sound waves and they detect echoes reflected of objects. So these are the different things like which are present in the IoT based systems or in the ultrasonic sensors as we have just considered it. So like this thing, many things gonna happen in near future. Let's hope for the best. So talking about the next sensor, which is integration with IoT, we've just discussed with that again. So examples of ultrasonic sensors are very much you can see here like how ultrasonic sensor looks like, and you have just seen that into the smart robots or the smart cars, which we are object detection cars model which we see in our job. So at that particular time you can just see this all kinds of ultrasonic sensors are present over the market. So you're gonna use like HCSR04 is very famous ultrasonic sensor which is used by most of the engineers or the beginners who are there in the robotics. So I think it's pretty much clear to you like how ultrasonic sensors will gonna work. Talking about Arduino, so Arduino is also a very great stuff when it's come to the thing like microcontroller, then it's a very good thing. So it contains tool to create interactive programmable electronic system. So it's a very basic board. It is developed in Italy actually. So how it looks like, I will give you one shot. So there are three kind of Arduino: Una, Mega and Nano. Nowadays there are many boards, but these three are the populars. Integrated IDE is there for Arduino coding. Programming language C, C++, and to be precise it is embedded C. Okay, IO pins are there for digital input output pins, analog pins. Shield are there to just protect that particular board. Sensors and actuators are present over there. and they are actually used, sensors are used to just process or just to sense the information from the environment, and actuators are actually responsible for making it into motion, right? So these are actually the thing. Raspberry Pi, you can say it's a single board computation which is developed by Raspberry Pi Foundation. So these are affordable, versatile devices which are designed for educational purposes, prototyping and various die projects. Now the thing is, Raspberry Pi is more advanced because it contains its own network cable. You can even connect it as Ethernet to it. Like when it's come to Arduino, you can't do it. Okay. First of all, second thing, the separate OS is there in which is not like Raspbian OS is there in Raspberry Pi, whereas Arduino doesn't contain any kind of OS in it, right? So these were the things. And what are the difference between Arduino and Raspberry Pi? So I just talked about this earlier also. It's an important difference. Like programming, when it's come to programming, so Raspberry Pi works on Python, it works on C, embedded C, right? Interactivity is there, so real-time interactivity is there in Arduino, whereas GPIO pins and operating systems are developed in Raspberry Pi for multitasking. Connectivity, so basic connectivity may require shields, right? But when it's come to the Raspberry Pi, so USB, Ethernet, Wi-Fi, Bluetooth and versatility connectivity is there. Projects like embedded systems you can develop, but from Raspberry Pi you can develop multimedia projects which involves the massive use of LED. Even you can develop a very simple display by just using one simple board of Raspberry Pi. Like generally when you talk about Arduino, it is more affordable or cheap. Like when it's come to Raspberry Pi is very much high in the cost. Like its cost around will be from 5,000, starting from 5,000. Like it's very much cheap, very much costlier, right? So Light OS is one more. If we talk about Light OS, so Light OS is a lightweight open source real-time operating system like RTOS, real-time operating system designed for Internet of Things devices. It is developed by UI, which is very popular company. Light OS aims to provide minimalistic and efficient operating systems specifically tailored for resource constrained IoT devices. So lightweight, it is a lightweight in device, it is more IoT focused, its connectivity is incredible. RTOS features real-time operation like you can do, which involves if you want to maintain many IoT devices together, then RTOS is for you. When it comes to modularity, so it contains some modular architecture over it, which enable developers to include all kind of necessary components in it for the specific use cases. Wide hardware support is there. Communication protocol software support for communication protocols commonly used in IoT applications. Low power consumption is there. When it's come to Light OS, development environment or development tools are provided with this OS so that you can develop enormous amount of applications by using it. When it's come to use cases, so it is useful in the smart home devices, industrial IoT, wearable devices like this. Like there is one more thing which is RIoT OS, which is real-time operating system. RTOS is a real-time. You can say when I just talked about real-time operating system, so Light OS is the one of the best example. So when I talk about the RIT OS specifically, so it's an open source operating system designed for Internet of Things. So it is especially tailored for the challenges of resource constraint. It is actually tailored, it's specifically tailored for the resource constraint embedded system, which we have discussed earlier in this video, right? So it's a lightweight, energy efficient, real-time operation, modular, supported platforms, IoT protocols, security features are there. IPv6 support is there, it's very much important. Development tools are also provided and use cases are in smart cities, industrial IoT, wireless sensor network, it is there. And the major thing is that it is open source. So you can just use this code and it's publicly available for you all so that it can be used by you to develop incredible applications. So like this. There is one more which is Contiki OS. It is specifically designed for Internet of Things and low power wireless system. Like suppose you are having a low powered wireless system, so Contiki OS is used, right? It's lightweight and efficient, so the resource optimization is great. Multi-platform support is provided and IPv6 support is provided for it. Modular architecture, talking about the modular architecture of it. So Contiki follows a modular architecture allowing developers to choose and include only the necessary components for the specific IoT applications, right? So these were some kind of things. Talking about the Tiny OS, so it is actually developed for low power wireless and embedded system, particularly data used by wireless sensor networks. We have discussed about that. Like all sensors are communicating wirelessly with each other through a network. So this thing is developed for that Tiny OS. It's very much popular in the field of development, right? I must tell you. So it uses NESC or you can say NSC programming language, NSSC programming language, which is actually a specific kind of a programming language in which the codes will be written. So like this thing, it goes on talking. I hope you loved this video. So today we have just discussed about IoT. It's a part 1 video. So part 2 is already uploaded. You can just go there and refer there. The notes were also there with the video. So I hope that you loved this video. And soon we will be back with another kind of videos on this channel. So just subscribe it. We are going to discuss many things in the podcast videos. So one podcast is already released. Another one will be released soon, later this week or this month. So let's see for the best. And if you have any kind of query related to IoT, and if you want an IoT specific podcast, so then you can just comment there in below, and I'm gonna create a awesome video with the awesome guest. Okay, so I hope you loved this video. See you soon, guys. Stay happy, stay safe, and all the best for your examination. Kill it hard, and don't forget to watch the part 2 video, because the half of the syllabus will be covered in that video. Okay, so till then, stay happy, stay good, bye.